Okay, so in this video I am going to explain the relationship between primal and dual types of linear programming problem. Very easy, very simple and very useful. Now we will see how to proceed. First we will see the relationship in between the primal and dual, and we'll take some examples to see the relationship through the examples, and we'll write the generalized form of the primal dual relationship. Okay, so in this video I am going to explain all these things, and in the next videos we'll take some another types of the example, and we'll take some another examples, and we'll explain some theorems, and we'll see how to prove the theorems with different examples. That is also important. So I think this particular topics is going to be divided in 2 parts or maybe in 3 parts. So we'll see in the next video. But first, in this video I am trying to summarize some basic concepts, and it will be useful for you to understand the concept of second part 2. That will be easy for you to understand if you are going through this order from part 1 to part 2. So okay, so now first I am going to write the relationship between, or we can say primal dual relationship. Just I am going to write the primal dual relationship. Very simple. First we should come to know what is the relation between primal and dual. Primal and dual, if the questions have given its objective function in the form of maximization type, then its dual will always be minimization type. And if I have given in minimization form, then dual will be maximization form. And number of constraints will change to the number of variable, and number of variable will get changed to the number of constraints, and the right hand side of constraints will become the coefficient of objective function, and the coefficient of objective function will become right hand side of constants. And the matrix A, whatever is going to be created by primal, it will get changed into the form of A transpose. This is the general relationship in between primal and dual. We'll take example and we'll see how this relation exists. Okay, now I'm going to take one example like a maximization types. Max z is equal to 3x1 plus 4x2 subject to x1 plus 2x2 less than equal to 4, 3x1 plus 2x2 less than equal to 6, x1 and x2 will always be greater than equal to 0. This is primal. What will be its dual? Now going to see what's the definition. If the objective function I have given into the form of maximization, it will get changed into the form of minimization form. So then I'm going to write the minimization z. Just for the identification, I am going to change this z to z star, and right hand side of the constraints will become the coefficient of objective function. So right hand side of the constraint 4 and 6 will become the coefficient of objective function. It means 4y1 plus 6y2. These two are the right hand side of the constraints will become the coefficient of objective function, and the coefficient of objective function will become right hand side of the constraints. So right hand side of the constraints, it means here 3 and 4 will become the right hand side of the constraints. So here, okay, so what questions have given into the form of maximization, and its constraints have given into the less than equal to inequalities form. So here in minimization form, inequalities form will get changed into the greater than equal to form. And next, here the coefficient of, see here, coefficient of constants. What is the coefficient of constants? 1 and 3. These are the coefficient of variable x1. 1 and 3. 1 from the constants 1 and 3 from the constants 2. It will get change from 1. So y1, 1 y1 is y1 plus 3 y2. Similarly, 2 y1 plus 2 y2 and y1 y2 will always be greater than equal to 0. So what this relation is going to show? A is going to change into the form of A transpose. So now whatever the matrix A is going to be created through this primal LPP is going to be changed into the form of A transpose. Now we can see here. So this is the relation, and just to check, I am going to see the matrix of this given LPP. What is the matrix here? If you are going to see here, A is equal to 1, 2, 3, 2. This is the matrix for A. What is the matrix for this one? What is the matrix for this one? 1, 3, 2, 2. If you are going to compare this one, so this row 1 and 2 is going to become the column, and 3 2 rows is going to become the second column. First row, first column, second row, second column. It means this A matrix is going to be changed into the form of A transpose. So these relations I already have written here in primal and dual relationship. Means A is going to be changed into the form of A transpose. It means the row is going to change into the column form. So here already I have seen in this example. Now I am going to take another example. There also will see all these, whatever the relations have written here, all these relations will exist into the examples. So now I am going to write the another example and we'll check. Okay. So now I am going to take the another example and we'll see what is dual. So for the primal, suppose I have written maximization types of question. Max z is equal to 3x1 plus 2x2 subject to whatever question we may take any question. 3x1 plus 4x2, 3x1 plus 4x2 less than equal to 12, and another example can take 3x1 plus 2x2 less than equal to 16 and x2 less than equal to 3. Whatever the questions, that is not an issue. Just I am going to take the examples of 3 constants, because just to move to see how these constants is going to be changed into the number of variable, and number of variables is going to be changed into the number of constants. So because 2 by 2 2 constants, 2 variables, we cannot see exact how these primal is going to be changed into the dual and going to fulfill these relations. Numbers of variables is going to change into the number of constants, and number of constants is going to change into the number of variables. Now I am going to take these examples, and through these examples we can see how many constants. There are 3 numbers of constants. It means in the dual of this form, so constants, number of constants will become the number of variable. It means dual of this, only 2 variables must exist. If there are more numbers of variable, it means that dual is not perfect of this given primal. So now going to change. So maximization is going to change into the form of minimization first, and right hand side of the constants is going to become the coefficient of objective function. So now the coefficient of objective function means right hand side 12 y1 plus 16 y2 plus 3 y3. So right hand side of the constants have become the coefficient of objective function for its dual, and the coefficient of objective function will become the right hand side of the constant. So coefficient of objective function 3 and 2. 3 and 2 means this is going to change in at the right hand side of the constants, and this inequality sign is going to be changed from less than equal to the form of greater than equal to, and A matrix A is going to be changed into the form of A transpose. It means whatever the coefficient of x1, first we need to write in first constants. So 3 y1 plus 3 y2, because there is no x1, so I am not going to write 3, I am not going to write the y3. Now here 4 y1 2 y2, and here x2 with coefficient 1, so simply y3. So how many variable? y1, y2 and y3. This will always be greater than or equal to 0. So now you can compare. If you are going to see this matrix, what is the matrix here? Matrix here x1 and x2, 3 and 4, x1 and x2, 3 and 2. There is no x1, 0, and x2 1. This is the matrix for this primal types of the LPP. Now I am going to see the matrix from its dual. So for with y1, 3, 4, 3 and 4, 3, 4, 3, 4, with x2, 3, 4, whatever I have written, 3, coefficient of a, just I am going to write, it's again to check, a is equal to, first I am going to write in this row, so 3, 4, 3, 4, 3, 2, there is no x1, so 0 and x2 1, it's right. Now I am going to write in this form. So first 3, 3, 3, there is no y3, so 0, 4, 2, 1, 4 with the coefficient of y1, 2 is the coefficient of y2, 1 is the coefficient of y3. Now you can compare with this. So in the column 3 and 3 and 0. So 3 and 0 have shifted into in rows. First column have become first rows. Second column 4 to 1 have shifted to second column have shifted to second row. It means A is going to give you A transpose. So A have already got changed into the form of A transpose. So now this is the dual form of given primal questions. So now I have changed the primal into the form of dual. Now if you are going to see its general form, then how to write the general form we will see. But here first you need to compare. How many variables are here in the primal? There are two variables, x1 and x2. So number of variable 2 in primal. Number of constants in dual 2. Okay. Number of variables is going to change into the number of constants. It's okay. Next, right hand side of the constants will become the coefficient of objective function. Right hand side of the constants 12, 16 and 3 will become the coefficient of objective functions 12, 16 and 3. This condition is also satisfied. Coefficient of objective function, right hand side of the constant. Coefficient of objective function 3 and 2 is going to change into the right hand side of the constants. It's okay. This condition is okay, satisfied. So this condition. Number of the constants will change into the number of variables. Number of constants, how many constants? 1, 2, 3. It will change into the number of variables. So number of constants 3. How many variables? 1, 2, 3. So number of variables is going to be changed. So now it is going to fulfill. Maximization types will change into the form of minimization. So all these conditions, whatever I have written from primal to dual, now going to satisfy these relations in between primal and dual, these examples. So we can say this examples is perfect. Have already converted from primal to dual, and this is the relation in between primal and dual. If we are going to write in the generalized form, so we can say in generalized form is very simple. Just we need to change according to the definition. According to the definition, in the sense, if you have written like a primal, like max types of Cx, means there is some coefficient of objective function like 2x1, 3x2 like this, and subject to Ax less than equal to B, and x will always be greater than equal to 0. Suppose this is the form of primal. How to write its dual? First, minimization will get changed into the form of maximization will get changed into the form of minimization, and just for the identification I am going to write z as a z star, and right hand side of the constants will become the coefficient of objective function. Suppose I am going to consider some another variable just for the identification. and here A will get changed into the A transpose. A will get changed into the form of A transpose. This less than equal to will get changed into the form of greater than equal to form, and coefficient of objective function will come to this side, which is transpose, and y will always be greater than equal to 0. So this is the form of, this is the primal, and this is the form of dual. It means whatever the matrix is going to be created by these primal types of LPP, at the dual it will give its transpose, and its coefficient of the objective function will become the right hand side of the constants, and the right hand side of the constants will move to the coefficient of objective function, and just for the identification I have given different variables name. So this is the general ideas how to convert from primal to dual, and this is the relationship that exists. So these are the just basic ideas over the primal and dual, and in next video we will take the another examples and we'll see how to solve that examples, and we'll see the relationship in between primal and dual. And there are some unrestricted relationship, because in variable we cannot say variables are negative, means variable cannot be negative. Variables x1, x2, x3, whatever the variables are going to be considered will always be greater than equal to 0. Suppose I have given that is the less than 0. So how to change this form into the, this primal form into the dual form? And there are some unrestricted sign. So variables in unrestricted in sign. So how to solve these types of problem if the variables are given in unrestricted in sign? So how to change these primal types of LPP to dual, to its dual? So we will see in next videos. And another things, there are some certain theorems that is very important. We should come to know all these theorems. So we will see all these theorems with some certain examples, how to prove all these theorem with some certain examples. So we will see into the next video. And I think this primal dual relationship I will try to finish in these two videos, that is the part 1, and in part 2 I will try to finish. But suppose it's not going to be finished in the part 2, so it will extend up to the part 3. So that is the ideas, and whatever I have explained in these lectures, I think you have got, and these ideas is the just basic ideas to get the relationship in between primal and dual. So it will help you in the next video to come to understand. So okay, thank you very much.